Hey everybody, this is Brad Dyke reaching out to you saying hi, how you doing? Today's discussion is going to be about thinking new ways to do with what you've got in your IT lab, as in back here, and inventing new ways to do new things with what you've got. Now, I've always been a big proponent of telling people that you have to think outside the box. Because once you got something running, right, you end up having the situation where you have to do it better, faster, cleaner, more efficiently, and less cost. So that's the normal dilemma of people who work with the limited funds they have for setting themselves up for their lab. So you have to ask the question. Computers being computers, they're just that. They're what we call input-output devices. They receive input and they put output out. The problem with today's technologies is that they're limited in the ability of putting input in. What do I mean? Well, in a nutshell, your key tips for your keyboard. You, with your little tip to tip to keyboard, is one of the most significant versions of input for your computer system. So it knows how you can do that. You can also do it with a mouse. The mouse does something similar. It's a different form of input. Point and click is the correct term I want to say. Another idea that you can have is what's called a binary to analog input device. Now, basically, all that really is a small digital board that will have a analog footprint. That would be like a temperature sensor, right? Something can tell the temperature, or humidity, or barometric pressure, or things like that. And these devices can give you some basic telemetry, and you use a digital analog conversion process to convert the analog input into digital input that it can become input for your computer system. Now, the challenge with that is the nature of the beast. Let me give you an example. When you deal with a device that, like, let's say a Raspberry Pi board, like this one, the thing about the Pi board is it's got a lot of functionality, especially this little 24 pin out kind of setup here you've got here. And this little guy can let you to any type of analog input that you want. And that analog input may be as simple as a analog camera, right? Thermometer, a weather system, and so on. But it's kind of tapped out. What do I mean by tap out? I mean, basically in a nutshell, you could go to any store and buy a Nest thermometer, or you can buy an interface platform that has all of the weather systems. That's the barometric, humidity, and all that control. And you can even do an atomic clock that puts in a kind of like a repository for your ultimate make sure you know what time it is kind of strategy, and so much more. But in truth of the matter is, it's pretty much been attempted. What hasn't been attempted is everything else. What do I mean? I mean, how do I turn my gear into something that can do more than just open windows, turn lights on, tell me what the weather is? Because basically, in a nutshell, that's what most of the gear around here is. The standard stuff that people discarded and I picked up, and I thought outside the box, and I said, how can I do this? Well, it may be kind of far-fetched, but you can do quite a bit, actually. You see that little device up there? Yeah, this guy right here. Well, he's a Hall Effect series inversion field generator. I know that sounds highly complicated. Big words. No, not really. I made that 20 years ago. I used big, huge, giant disc platters. And those platters basically, have the ability of generating what's called a nominatical or a nominal magnetic field. Hang on a second, let me show you what I'm talking about. So, this is a hard drive. Not the kind of hard drive that you're familiar with. This was 30 plus years ago on a StarDAC platform or a Harris 4000. So here we have a DVD, CD, and here we have a 100 meg one platter set hard drive platter. Now let me give you a comparison because this is important. So this is a hard drive, 15,000 RPM hard drive. It's a Seagate standard drive. It fits almost in the whole of this, and I've got 20 of these. But basically, in a nutshell, this is a normalized magnetic field. It carries a single charge ratio, and the heads would strike the surface to change the nature of that charge. This is what we call a hard drive byte, or in actuality, bit. 8 bits make a byte, and so on. This is an aluminum and coated spacer ring designed to space between the platters. And imagine another 19 of these and 19 platters, and you have basically a very, very heavy hard drive that I took apart many, many, many years ago. And I thought, oh, well, this is pretty cool. So I took something called a Hall's effect, a magnetic Hall's sensor. They sell them today, and you can actually get the ones that are digital. So basically on one end, it has a digital converter set instead of using analog, and it flips it into a digital 1 or a 0. And that Hall effect, all it does is it monitors magnetic fields. Now, the cool thing about this is, what can you do with this? You can do a lot. So, if you had a computer system, it was in your house, and you've taken a few strikes of lightning, okay? You can devise a pretty simplistic Hall's effect field environment that can actually give you the ability of determining and sensing magnetic charges. One of the key details about magnetic charges is sometimes how they interact with lightning. Now, you can do a lot more with this. I'm just giving you just a tiny scratch of the surface area. With an additional electrostatic sensor, you can actually determine how close a lightning strike was to your house to tell you if you've suffered any damage. Now, you're thinking to yourself, what do you mean damage? What could I have had wrong? What could have broken in my house? Well, the truth of the matter is Wi-Fi. If you look all through your house, you've got Wi-Fi everywhere. And Wi-Fi is just a little tiny wire with very thin gauging capacity. And static discharges can really wreak havoc on those Wi-Fi systems. Mostly by just simply passing high voltage through your wire, going into the electronics and damaging the electronics itself. So when you have yourself, for instance, let's say you set up a cluster and you've got 10 of these little guys in your house, and you got a PC server as your home. These guys are sensitive because they have, some of these versions of these boards have the ability of doing Wi-Fi. And if that's the case, then what you've got is a device that can be damaged. Now, you're thinking to yourself, why would I do that? Well, okay, let's jump in the future, right? The spaceships of the future are the houses we have today, okay? And when you look at the nature of a spaceship needs to understand the environment that's around it so it can be optimal to protect itself. Thermal stack sensors, static discharge sensors, Hall effect sensors with a digital conversion system, putting input into your computer system over a graphical mapping of your home where these sensors are located can give you a sense of what's around you and what you can't see with the human eye, but what can affect your home. And that's the value of that. Now you're thinking to yourself, well, how expensive is this? Well, the Hall effect sensors are about $2 a piece. They're very easy to get a hold of. You just order them at an electronics store. Your most investment is going to be the transport. That means the wiring that you would have set up or the way of communication. But you can cheat on that. You can set up a wireless module that will send the information and there's no wires needed. And you have like a small Pi or an Arula or some other very small, easily powered unit that can just get the telemetry and send it to your server. You only need 4. Actually, technically, you only need 3. This is important. Because with 3 points in any space, you can identify any source from any direction. Very important. If you have 4, you can actually generate a much more detailed positioning of where that comes from. Now you're thinking to yourself, wait a minute, wait. We're talking about computers here. Why are we triangulation? What's the thing about triangulation? Why do we need that? Well, good point. So, if you add also a radio transceiver into your equation, you have the ability, and you've built the ability, to be able to see where radio waves come from. You have the ability of seeing static discharges from like lightning strikes or power surges or things like that. You'd have the ability of course, having the weather system to tell you additional information on top of things that are happening local around you, and magnetic field sensors telling you if there's anything not odd or nothing, it's normal, and they're basically giving you kind of a picture. Now, for all of you nerds out there and space jockeys, this is what we call a sensor array on a spaceship. Now, what happens with a spaceship is they have what's called the sensor pod arrays, which are usually set up in 3 or 4 or 6 capacitances, because in space, your potential effect is from many different directions. So you have to have very good capacity. But on Earth, not so much. So if you wanted to take your home server / environment to the next level and think outside the box to make more functionality out of the gear that which you have at home, then this would be a really cool idea. So if you live in Nebraska or in the forests or in the deserts, this is really cool because those environments introduce what's called either no density or density. And what that means is you have a lot of zero activity in like deserts and open arid areas like tundras and so on, which means if anything happens, you got it. You got it documented, you know what it was and where it was. Now, on the dense side, it's the opposite, but with the same effect. Remember, guys, I'm telling you, use your computer systems outside the box. Think what you can't see. And if you invert that from what you can see, you have a lot of data there. Unknowns, black spaces that change or caveat for some reason. You should ask the question, why? Because something happened you couldn't see, and this is how you can see it. Now, let's take it to the next level. I talked to you guys about a Dell 3500 chassis platform, right? And I talked to you about, channel ways, think outside the box, and things like that. But what I didn't tell you is how you can build your own small micro enterprise environment. And it would take you roughly about 2 primary boxes, one acting as your primary node and your secondary node. They work together for load balancing workloads. In other words, they combine their workloads, but they can also be failover if one dies. That's good. Now that should be your home platform. But don't give your platform the responsibilities of looking at your data. Instead, take micronodes like these, and you have them as processors, right? They receive the telemetry of your home, and they'll tell you where information is coming from because of the triangulation effect that what you're doing. So that would mean basically you'd have one node pod for one of these guys, another node pod for another, and a third for the third, a minimum. You might want to do more for higher accuracy, but no more than I would say 6 or 12. But basically all you've got are the 3 endpoints necessary for sensor triangulation. I don't care what the sense is, electrical, heat, whatever. But when the 3 sensors can see it from different aspects, the triangulation mathematical equation that it does will tell you exactly where it is. Now, if the paranormal investigators ever took this strategy to themselves, they could see ghosts or whatever those things are really easy. And they know exactly where they are and where they're coming from and where they're going. I'll get into that one day down the road. But it has a lot to do with frequency and electronic ability to sense electrical discharge versus retraction. But different discussion. Anyways, back to what I was saying. You have 2 primary nodes in your house. They can be small nodes with capacity. That's about all you need, about 8 terabytes at max. And then you can use either the Dell stations, like the 70 series up there, or you can use Pi's, And then you collect the data. It takes time. It's not a joke. And there's some software development involved and so on. But that's what I've been telling you guys. Think outside the box. They're not hard to establish and set up. It's the magic is how you bring it into your, what we call the graphical map. The graphical map is your house. So basically all that is a diagram of the shape of your house, indicating north, south, east, west. And at that point stage, you could get a little bit more radical. You could zoom out and put your entire property into the equation with your house in the middle. And the sensors are strategically placed on the outside of the house so that they can see exactly the same space as all the other sensors. That's important. Once that's done, when a flare-up happens or somebody lights off a fireworks and you can actually see the heat signature because you have thermal sensors out there instead, they can very quickly triangulate, put the effect on your graphical map of where that blip on the radar came from, and you have some information. Now, I am kind of letting out some secrets here. The technology that I'm referring to can see much more than just what's around your house. But that's my professional world. This is my home lab world, and we only have so many dollars to work with, and you can roughly do this for under about $300 to $400. Don't get fancy, don't get crazy. Just learn how to bring them in, and then you begin to develop the exact same kind of functionality that you would see in a spaceship, where something might be coming up on you really quickly and it's hot and it has a gravitational field, or in this case it has a magnetic field, and you have your sensors out there doing what needs to be done. So with that being said, it doesn't matter what kind of sensor you put into the equation is what I'm driving at, because if you have a way of taking the input in, you treat it as metadata. That basically is a value of 1 to whatever, and that value would go to a kind of like table, and it's a database of sorts, and it would log the metadata, and then it would give you position and triangulation information, which would tell you how severe whatever it was and where it was near the house. And you could even put threat factors in there, such as you live in a forest and you're fearful of forest fires. This could show where in your property that fire can come from. You can catch it quickly and extinguish the flames before it could travel your yard and get to your home. It's real, people. A lot of people lose their homes because homes can't be picked up and moved away, and they don't have eyes or ears to know that there's something coming. This isn't a bad strategy to have in regards to that. And if you were really cool and smart, you'd have a little robotic arm with a little water squirter that would pop up and squirt that flame and put it out. But hey, it is what it is. My suggestion is, if you start detecting airborne fire particles near your house, that you should have a house-wide sprinkler system that starts saturating the house with water so it can't burn very easily. And that would be probably smarter. You can do a lot with very little water if you sprinkle it in the mist and you start saturating everything with moisture, so it's hard for fire to go. But like I said, it doesn't really matter. Can you do this in a car? Yes. It would be a 5-node system, and you would have triangulation sensors probably on the top of the car, and so that the sensors can sense front, back, left, right, and all the variables in that equation. With that being said, sky's the limit, guys. Now, for those really seriously techno nerds who want to make new things come into fruition, like a spaceship or sci-fi or whatever, okay, here it is. There is something known as an 8K camera. There are also certain kinds of 8K cameras that have 180 or 360 view capacity. In other words, they look like a dome ball, right? And that dome ball can 360 the area environment that it has. Now, this is not cheap, but you can stream that data in and negativize the data. Okay, what do you mean? Well, we talked about a home cluster system, right? That can take anything in as long as you can convert it to digital. This is an exception because it's digital. So an 8K camera sees things you cannot see. Very important detail. I saw this show, I think it was called Skinwalker Ranch, and they're so desperately trying to get pictures of stuff. But I noticed that all the camera gear they have is not really capable of doing what needs to be done. So what needs to be done is you need to see what you can't see. And the only way to see that way is to use ultra high resolution cameras that are digital based and have what's called stream buffering. In other words, they have a large amount of memory inside the camera system that can take a large amount of data very quickly, because it's taking a picture of the environment. Now, in that environment, there are things you can't see. They are anomalous data endpoints in the video. In other words, they have no value because you can't do anything with them because your eyeballs aren't capable of dealing with it. But it doesn't mean it's not there. So you use it, you stream the data into a digital format and you identify those layers and you start stripping away the spectrums. And by the time you strip away all of the visible spectrums, there's something still there. Whatever that is and what it's doing is what you want to see. You don't need to see it, you just need to know it's there and it's moving or it's whatever it's doing. And so imagine, you've got this camera set up and you've got 3 of them, right? 3 different places, 1 mile apart, creating a triangulation model window. They have their small little Raspberry Pis that send out the telemetry reports out, and they take snippets of data. In other words, they take a picture of the sky for a certain amount of time. And as they take a picture of the sky flows normally. What doesn't flow with the sky is what you want to pay attention to, but you can't see the anomalies because it's not visible to you yet. So what you do with this strategy is you'll break down the metapairs, you'll strip away all the visual spectrum of the sky that you took a picture of, and whatever's remaining is what you need to investigate. If you've heard the term, take a picture of the stars and inverse the picture. So stars aren't white and blackness isn't black. Instead, the black becomes white and the stars become black. And you start to see things you never thought were there before. It's the same strategy, but this time you're doing it digitally. You're stripping away the visual spectrum that we can see. And if you, let's say, had a stealthy kind of strategy out there, whatever stealth it would be, it could not hide from this. It just can't. 8K can see a lot. And as cameras grow in more capacity, it's not necessary to have the ultraviolet spectrum aspects that we're not allowed to see. Well, that's a whole different discussion. But you can see the nature of its interaction in the sky with everything else. That's a very important detail. What you thought was not even visible in your eye turns out to be a ball blur traveling across the sky, or you're picking up thermal registrations in areas because of the way it waves the air. You know what I mean? You've seen that, the illusion of in the desert where you have thermal currents that create mirages, and so on and so on. You can now see the metrics and the functionalities at the basic physics level and get an idea. So that's extreme, I know. Why not? If you want to turn your home server environment into something more capable, functional, and so on, that's how you do it. Now, I strongly recommend that you do not put weapon systems in your home or do a Tony Stark thing. Nah, no need for that. But camera systems, security, lock sacks, thermal registrations to look for to be prepared for any kind of fire that might happen. Static discharge sensors to determine that your house has been struck by lightning and that you might have some real problems, and so on and so on and so on, because it gets expensive, when those kind of things happen. And this is a way to expand the nature of your IT lab into your home environment that allows you to see a lot more. Now, I put this video out here for you guys because I've got a lot of you saying, "Oh wow, I'm really tinkering with this stuff," and then they build their stuff. What ends up happening? Well, it goes over there in file 13 cabinet, right? And then you get the next greatest stuff. But what if you could take your stuff and you're cost effective. Now, in other words, you're not buying stuff that has a lot of power to it, but it's cost effective. It's doing everything you need to do, and you can add to it. And not only add to it, but you can scale your environment. You can bring in a sensor bus. The sensor bus is basically a common home where all the data comes in to a couple of USB cables that are sending telemetry to you or to your systems and so on for whatever sensor setup you want. It's time to start stepping out of the basics of IT and start finding some really cool things out there that you can start to see and not see and still be able to interact with it. Well, listen, this is a cool little fun thing. It's a hardware discussion topic. 34 some odd years now I've been doing this stuff. I always take the time to bring something to the people who just don't have the resources, but they get stuff, right? They want to play, they want to have some fun with it, and you know, that's the whole point of this. And then the next question is, what can you do next? You know, that's how integrated light technologies came to existence. This is how LucasArts came into existence and all of their really cool things. And all these other people who were sitting in a garage tinkering, and they found something that was so much fun that they made a career out of it. I endorse that for you. I really want you guys to be able to have some fun, recycle this industry that is so geared to make you throw things away. I compel you, don't do that. Recycle for sure, reuse if you can, and just don't fall into the Apple mindset of buy my phone for 14 months and go buy the next one. That's just so much waste. And there's so much potential in the phone, but they actually gear it so it kind of doesn't work because it's not making money for them. Start having some fun for yourself and stop paying the people who just arbitrarily want money and throw and be wasteful in this world. We really shouldn't do that. Well, this is Brad Dyke signing off. This is my hardware video for this go around. I'm gonna let you go. I got to do a couple other videos, one on the software side of things, and two on IT professionals, on how you can develop your professional skill sets as you go forward and become more of a person who can mentor, not just do your job. This is Brad Dyke. God bless, take care, and have a great weekend.